Welcome to MRL. In this learning session, we'll be learning about the coordinate geometry of 9th standard new syllabus. Now this is the second part of the study of coordinate geometry, and in this part we'll learn how to find out the various distances of points in a coordinate plane. Now let us begin. Now here we have distance of points on x-axis and y-axis. What does this mean? Now we have x-axis here, x dash. Point A is a point on x-axis, and the distance of point A on x-axis is OA, and that is 6 units. Similarly, there is a point C on x-axis. The distance of point C on x-axis is OC, and that is 10 units. The distance AC is OC minus OA, and that is 10 minus 6, and that is 4 units. So that is 4 units. Similarly, the distance of a point B on y-axis is OB, and that is 5 units. The distance of a point D on y-axis is OD, and that is 8 units. And the distance BD is equal to OD minus OB, and that is equal to 8 minus 5, and that is 3 units. So that is how we find the distance of points on x-axis and y-axis. Please remember that. Now coming to the next point, the distance of a point from origin. So we have a point P in a coordinate plane. Now O is the origin. We have to find the distance OP. Now to find the distance OP, drop a perpendicular PA to x-axis, that is OX, and we get a triangle OAP, which is a right angle triangle. And by applying Pythagoras theorem that OP square is equal to OA square plus AP square, we can find OP. Now that is, let us see how to do it. Now OP square is equal to OA square plus AP square, and OA square is 4 square, and AP is 3 units, that is 4 units, okay, 4 units, that is 4 square again. So 4 square plus 4 square, so 4 square is 16, 4 square is 16, 16 plus 16 is 32, square root of 32, that is square root of 16 into 2, that is 4 root 2 units. So therefore the length OP, or the distance of point P from the origin, that is OP, is equal to 4 root 2 units. So that is how we find the distance of a point from origin using Pythagoras theorem. Remember that. Now coming to the next point, the distance between points lying, one point is lying on x-axis and another point is lying on y-axis. So let us take this example. A is a point on x-axis, B is a point on y-axis. We want to find the distance AB. Now to find the distance AB, again if you see here, AOB is a right angle triangle. We can apply Pythagoras theorem again. Therefore AB square is equal to OA square plus OB square. And now OA is 4 units and OB is 3 units. So substituting, we get 4 square plus 3 square, square root of that, square root of 16 plus 9, square root of 25, and therefore AB is 5 units. So therefore again here we have applied Pythagoras theorem to find the distance AB, okay, between 2 points, one lying on x-axis, another lying on y-axis. Remember that. Now this is distance formula, a very important formula, and this formula is used for different applications, but in particular we use this formula to find out the distance between two coordinate points in a coordinate plane. Now the formula is very simple. If you want to find the distance AB, that is between AX1 y1 and BX2 y2, then the formula is AB is equal to square root of x2 minus x1 whole raised to square plus y2 minus y1 whole raised to square. So that means x2 minus x1 whole raised to square plus y2 minus y1 whole raised to square. But let us see how to derive this. So let us understand the derivation. Now let us consider in a coordinate plane AX1 y1 is a point and BX2 y2 is another point. Now we want to find the distance AB, or the length AB, or the measure AB. Now drop a perpendicular AM to OX and also BN to OX, and also drop a perpendicular AC to BN. Now if you observe here, a triangle ABC is formed, and the triangle ABC is a right angle triangle. So by applying Pythagoras theorem, we have AB square is equal to AC square plus BC square, AC square plus BC square. But AC and MN are equal because this is a rectangle here, that is AC NM is a rectangle, therefore AC is equal to MN. I can replace AC by MN, so therefore it becomes MN square. And also we have BC as it is BC square, but MN length, MN, we can find out MN, that is ON minus OM, therefore it is ON minus OM whole to square. And we can find out BC by taking the length BN and CN, so BN minus CN will give you BC, therefore BN minus CN whole to square. But we know that ON is the distance, ON is nothing but x2 and distance OM is nothing but x1, so we have x2 minus x1 whole to square here, and the distance BN is y2 and CN is nothing but AM, and that is y1, and therefore y2 minus y1 whole to square. So now AB square is equal to x2 minus x1 whole to square plus y2 minus y1 whole to square, and therefore AB is equal to square root of x2 minus x1 whole to square plus y2 minus y1 whole to square, and this is the distance formula. Now let us use this formula to find the distance AB. Now let us understand what is x2 here, 6 units, so 6 units. And what is OM here, 2 units, so 2 units, that is 6 minus 2 whole to square. What is y2 here, y2 is again 6 units. And what is y1 here, 4 units, so 6 minus 4 whole to square. So 6 minus 2 is 4 square, 6 minus 4 is 2 square, 4 square is 16, 2 square is 4, 16 plus 4 is 20, so square root of 20 is 4 into 5, so it will be square root of 4 into square root of 5, and square root of 4 is 2, and that is 2 root 5 units. So the length AB is 2 times 2 into root 5 units, 2 root 5 units. Therefore, the distance formula is used to find the distance between two coordinate points, and that is the first important application. But there are various other applications of distance formula, and let us learn that later. But before that, let us apply this distance formula to find out the distance of AD. Now we have three coordinate points here, A34, M96 and D71. Now if you want to find AD, I can apply distance formula. Now how to apply distance formula? First thing is, either you can directly go for the construction and find it out by applying Pythagoras theorem, or apply the distance formula. And what is the distance formula here? This is x1 x2, this is x1 y1, and this is x2 y2. So now x2 minus x1 is 7 minus 3, 7 minus 3 is 4 square, and 1 minus 4 is minus 3 square. So 4 square plus 3 square is 25, and square root of 25 is 5, and therefore here we have AD as 5 units. Remember that. Similarly, we can find out AM as well as MD by using distance formula. You can try finding out AM and MD by applying distance formula. You will find that AM is equal to 2 root 10 and DM is equal to root of 29. So please remember that. Now, what are the other important applications of distance formula? So distance formula can be used to find whether the given three vertices are the vertices of a triangle. That means you will be given three different coordinate points, and you have to prove that those three coordinate points are the vertices of a triangle, and there is a procedure for that. To find if the given vertices are the vertices of a square, that means you will be given four different coordinate points. You have to join them and prove that those four given coordinate points are the vertices of a square. Again, there is a procedure for that. To find if the given points are collinear, if you are given 3 points and you have to prove that the 3 points are lying on the same line or they are collinear. And to find the area of a triangle using Heron's formula. See, you are given a triangle. First of all, you have to find out all the three distances of the triangle, or the measures of the three sides of a triangle, and then use Heron's formula to find the area of a triangle. And to find the point on x-axis which is equidistant from two given coordinate points, and also to find the distance between two coordinate points, which we have already learnt. Now all these applications have to be learnt, and we can learn it, and I have already explained these applications in one of the videos of CBSE 10th coordinate geometry syllabus. Please go through that video if you want to understand these applications. Otherwise, these applications are not discussed in your coordinate geometry 9th standard syllabus. Therefore, remember, the distance formula is AB is equal to root of x2 minus x1 whole to square plus y2 minus y1 whole to square. And remember also that whether it is x2 minus x1 or x1 minus x2, whether it is positive or negative, it doesn't make any difference, because any square term is always positive. So please remember that. Now the next very important discussion is reflection. Now, we already know what is reflection in light in physics. Reflection is a phenomenon of light. reflection also produces an image of an object which is an exact replica of the object, and when it is placed in front of a mirror, generally when we talk about a plane mirror, we know that what are the features of the image formed by a plane mirror. When an object is placed in front of a plane mirror, an image is formed in front of the back side of it, and the distance of the image is equal to the distance of the object in front of it. So therefore we have a mirror here, a plane mirror. AB is the object, A dash B dash is the image, and if you see the size of the object and the image are the same, and the distance of the object and the image are also same. So that is what is a reflection of light, which will be learning in detail in physics study. Now, image of a point in a line. Let us say a point is there P, and there is a line AB, and drop a perpendicular PM, extend it to P dash such that PM and P dash M are equal. Then P dash is called as the image of P in line AB. So please remember that. So therefore, again I'll repeat, P is a point and P dash is the image of P. For that, draw a PM perpendicular to AB and extend it to P dash such that PM is equal to P dash M. Then P dash is the image of P in line AB. So please remember that. Now coming to the next important discussion, reflection of a point in X axis. Now we have a point PXY here, and extend P, draw perpendicular PM to OX, extend it to P dash such that PM is equal to P dash M. Then P dash is the image of P. If the coordinates of P are XY, then the coordinates of its image P dash coordinates are X and minus Y. Therefore remember, the reflection of a point PXY in x-axis is equal to P dash X minus Y. So please remember this. Now if you take the reflection of a point in y-axis, we have point PXY here, and P dash minus XY is the image of PXY or reflection of PXY, and the coordinates of P are the coordinates of point P is XY, whereas the coordinates of point P dash is minus XY. So please remember that P dash minus XY is the reflection of PXY, and P dash minus XY is the image of PXY. PXY when reflected in y-axis has the image P dash minus XY, and therefore the reflection of XY in y-axis is always minus XY. So that is what is the sign convention which we are following in different quadrants. You know, this is first quadrant, this is second quadrant, third quadrant and fourth quadrant, and these sign conventions we follow. And only what you have to remember here is that P dash is the reflection of P, P dash is the image of P. Here P dash is the reflection of P or P dash is the image of P, and that is what you have to remember. That is about reflection of a point in x-axis and y-axis. And this is very interesting here. We have a triangle AMD. The coordinates of A are A34, M96 and D71, and this in y-axis, see this the triangle AMD is reflected in y-axis, and we get image of the triangle AMD, that is A dash, M dash, D dash. Rather, A dash is the image of point A, M dash is the image of point M, D dash is the image of point D, and if you look at the coordinates, if it is 96, it is minus 96 here, and if it is 34, minus 34, and if it is 71, it is minus 71. So this triangle, which is the reflection of this triangle, is exact replica of the triangle AMD, and please remember that. Now the explanation of this would be, in the figure, triangle A dash, M dash, D dash is a reflection of triangle AMD. A dash is the image of A. I have already told you that A dash is the image of A, and similarly M dash is the image of M, D dash is the image of D. Image of AXY in y-axis. Image of AXY in y-axis is A dash minus XY, and it's very clear, A dash minus XY is the image of AXY. Similarly, M dash minus XY is the image of MXY. Similarly, D dash minus XY is the image of the point DXY. Now if you find out the length AD, and we can find out the length AD by applying Pythagoras theorem, or we can go for distance formula. If you apply the distance formula to find AD, as I have told you, AD is equal to x2 minus x1 whole square plus y2 minus y1 whole square, and that is equal to 7 minus 3 square plus 1 minus 4 whole to square, 4 square plus minus 3 whole to square, that is 16 plus 9, that is square root 25, and that is 5 units. So therefore the length AD is 5 units. Similarly, the length A dash D dash is also 5 units. We can take this as x1 x2, this x1 y1, and this as x2 y2, apply distance formula and find the length A dash D dash as I have done here. A dash D dash is equal to square root of x2 minus x1 whole to square plus y2 minus y1 whole to square, and that is minus 3 minus of minus 7 whole to square plus 4 minus 1 whole to square, and that is we get 4 square plus 3 square or 16 plus 9 square root of 25. Again it is 5 units. So therefore again it is 5 units. That means the reflection has preserved the lengths of the sides of the triangles. So that completes the study of coordinate geometry of 9th standard new syllabus. We have learnt in this particular chapter in 2 parts, part 1 and part 2. So please go through both the parts, study all the basics, understand the basics, revise the basics, and then go for application of the basics what you have learnt. So go through it, listen to what I have spoken to you, and read and scribble in a book for your reference. Okay, thank you.